Welcome to the Explainer. Today, we're going to tackle a problem that, every data professional feels in their bones. What do you do when you are staring at a massive, messy data set? It's that feeling, right? It can be totally overwhelming. You've got this absolute treasure trove of information, but it's just a chaotic jumble of rows and columns. Trying to find a meaningful signal in all that noise, it feels next to impossible. So, where on earth do you even start?
Well, the answer is surprisingly simple, but it's also incredibly powerful. You don't try to swallow the whole ocean at once, no. You find one single significant thread, just one focused starting point, and then you just start to pull. And as we're about to see, that one thread can unravel the entire puzzle.
So our thread for today comes from this huge, publicly available dataset from Olist, which is a major e-commerce player down in Brazil. We're talking millions of orders, thousands of products, spread across this huge geographic area. I mean, it is the perfect poster child for real-world data chaos.
All right, so first things first, we have to narrow our scope. We can't possibly analyze the entire country at once. We need to find the most impactful area to start our investigation. That's going to be our first anchor point.
And right away, the data basically screams the answer at us. When we look at the orders by state, São Paulo or SP isn't just the leader. It's in a whole different league. By focusing here, we're getting right to the heart of Olist business, which means the patterns are going to be stronger and the insights way more valuable.
Okay, cool. So we've got a location. Next up, we need a time frame. Diving into the source data, it's pretty clear that 2017 is the only year with a full, continuous set of weekly data. The other years, they've got missing weeks, they're incomplete. So, just so we know our analysis is built on solid ground, we're focusing on São Paulo in 2017.
Now we get to the next crucial choice. We want to understand what's driving revenue, right? So should we follow the people who buy stuff all the time, the frequent customers? Or should we follow the products that get bought all the time, the frequent items? And this is a big one, because this choice is going to define pretty much everything that comes next.
And honestly, the data makes this choice for us, and it's not even close. The items that were purchased frequently, we're talking just 10 or more times, they account for the vast majority of all the revenue. Meanwhile, even the most loyal customers, they make up a tiny, tiny slice. The takeaway here is crystal clear. If you want to understand the money, you got to follow the stuff people are buying.
Okay, so to analyze these items, we need a tool. We're going to use something called cosine similarity. But forget the math for a second. Just think of it like a shopping taste score. It looks at two different baskets of goods, say what people bought in week 1 versus week 2, and it gives them a score based on how similar they are. A really high score means people's tastes were pretty much the same.
So what did we do with it? First, we used our shopping taste score and applied it to time. We compared week 1 to week 2, then week 2 to week 3, and so on, for the entire year of 2017 in São Paulo. This let us see exactly how buying patterns were changing or not changing over time.
Now that's cool and all, but we still have thousands of different items. It's still way too complex. So we bring in another tool, non-negative matrix factorization, or NMF. Let's just call this our recipe finder. NMF is this brilliant technique that can look at thousands of ingredients, or in our case products, and figure out the few core recipes that make up pretty much all the meals.
And the result is absolutely staggering. Out of nearly 3,000 frequently bought items, NMF discovered that just two core shopping recipes or components could explain 90% of all the week-to-week sales variation. We just took a massive amount of complexity and boiled it down to 2 simple, understandable patterns. That's huge.
Okay, so that's a really powerful way to look at things over time. But now we get to the real breakthrough. What happens if we take that same exact logic, this idea of a shopping taste score, and instead of applying it to time, we apply it to geography, comparing city to city instead of week to week?
So here's how that works. First, we calculate that shopping taste score for every single possible pair of cities in São Paulo. Then, if any 2 cities get a score over 0.4, which means their shopping habits are pretty similar, we draw a line connecting them. What you end up with is, well, it's kind of like a social network, but for cities, all based on what they buy.
So we've built this thing, right? This social network of commerce that connects over 460 cities across the state. The big question is, what does its structure actually tell us? What hidden pattern did we just uncover?
And this right here is the big aha moment. The network wasn't one giant tangled mess. No, it cleanly split our original huge problem into two completely different subproblems. On one side, you have these clusters of interconnected cities where their shopping behavior is linked. To analyze them, you need graph theory. And on the other side, you have a whole bunch of independent, isolated cities. Their behavior isn't linked at all, so you can just analyze them with conventional stats and machine learning.
So what does that actually look like in practice? Well, out of about 460 cities, roughly 170 of them are part of that interconnected graph. The other 290 are just kind of floating on their own, behaving independently. Now, we haven't solved the whole problem yet, but what we've done is successfully map it into two smaller, much better understood problem types.
And as the original analysis puts it, this is the whole ball game. Knowing what cannot be treated as IID and what can be is a very useful finding. Figuring out which parts of your data you can treat as independent and which parts you absolutely can't, that is a huge win. It tells you exactly how to approach your modeling.
And here's the best part. This isn't some one-off magic trick that only works on this one dataset. This entire process, from narrowing the scope all the way to building that similarity graph, it's a repeatable blueprint. You can apply this to almost any large, complex dataset you can think of.
So let's just recap the blueprint here, step by step. 1. Aggregate your data around some key dimension, like a city or a week. 2. Calculate a similarity score between each of those things. 3. Use that score to build a graph, connecting the similar ones. And 4. Analyze the structure of that graph, the connected parts and the disconnected parts. Those are your new, simpler subproblems.
So, what's the big takeaway from all this? By finding and just pulling on that one single thread, we've transformed total chaos into real clarity. We started with one massive, messy problem, and we ended up with two smaller, well-defined problems that, frankly, data scientists already have amazing tools to solve. That right there is the power of this approach.
Look, every complex dataset has a simpler, hidden structure just waiting to be found. So the real question is, are you ready to find that single thread and start pulling? Thanks for joining us on The Explainer.